In this video, we're going to integrate some more complicated expressions. As in an earlier video, you'll get the greatest benefit from this if you pause the video when I say so and try to do the integral for yourself. So let's go on and look at the first one. There we are. So pause the video, please, and see if you can find the integral. You should be able to. Well, did you manage to do it? The pattern is very similar to earlier integrals. We have a square root, we have a plus. This rather suggests something like 1 plus sine squared u is cosh squared u. And so 4 plus 4 sine squared is 4 cosh squared. So if we can turn 4 plus 4 sine squared into 4 cosh squared, if we can do that, our square root is then nice and easy. So this suggests that we put x minus 3 equal to 2 sine u. If I do that, under the square root sign, I'm going to have 4 sine squared plus 4. Well, if that's the case, then dx is equal to 2 cosh u du. And so our integral is equal to the integral of 2 cosh u du divided by the square root of 4 sine squared u plus 4. Whole purpose of doing this, we've got the integral of 2 cosh u divided by the square root of 4 cosh squared u. That is just the integral of 1 du. And that, of course, is u plus c. X minus 3 is 2 sine u. So u is going to be r sine x minus 3 over 2 plus c. Okay, let's see how we get on with the next one. Once again, stop things, pause the video. You, again, I think ought to be able to do this. Okay, pause the video if you haven't. Well, did you manage to do this? In the previous example, we already had the expression under the square root sign in completed square form. And that is the trick, that we write this as the integral 1 over, if I want to complete the square, then I'm going to write square root x squared minus 4x, halve the coefficient of x, square it and add it, and I must take away 9 to make it work. This is now the integral of 1 over the square root of x minus 2 squared minus 9. So this time, we want to think of cosh squared u minus 1 is sine squared. And so 9 cosh squared u minus 9 is 9 sine squared. So that suggests that I want to put x minus 2 equal to 3 cosh u. If I put x minus 2 equal to 3 cosh u, I now get 9 cosh squared minus 9. I like that. This tells me that dx is equal to 3, I lost the u, sine u du. So my integral becomes the integral of, losing everything, there's a dx. Replace the dx by 3 sine u du. divided by square root x minus 2 squared is 9 cosh squared u minus 9. Whole purpose of doing it, it turns the bottom into 3 shine u. This becomes the integral of 1 du, which is u plus c, and u is equal to, well, x minus 2 is 3 cosh u, so that's r cosh x minus 2 over 3 plus c. So just going one step at a time. Started off with something already in completed square form. If you have a polynomial under the square root sign, a quadratic, complete the square and it will turn into something that you will be able to do. Let's see what happens next. Okay, there we are. Pause that and see if you can cope. Well, did you manage that? I don't know what you did to start with. You might have gone straight for completing the square because of what we've just been doing. X squared minus 4x plus 4. That means plus 9. That's now equal to the integral of 1 over x minus 2 squared plus 3 squared dx. Well, we know that 1 plus shine squared is cosh squared, but we've got no square root sign. And when we don't have a square root sign, it is better to think of tan squared plus 1 equals sec squared. That tells us that in this case, we would put 9 tan squared plus 9 equals 9 sec squared. And that suggests that we put x minus 2 equal to 3 tan u. That gives us that dx is equal to 3 sec squared u du. And let's put all that into the integral. Dx is 3 sec squared u du divided by 9 tan squared plus 9, which is equal to the integral of 3 sec squared u over 9 sec squared u du. Cancel things out. Integral of 1 over 3 du, which is u over 3 plus c. U, that's 1 over 3. U is x minus 2 over 3 arc tan x minus 2 over 3 plus c. So, completing the square still worked for us. And this is the last one. What happens here if we pause the video and let you carry on and try and do that? Well, given what we've done so far today, some of you might have started off on this one completing the square, but this is going back to the ordinary A level. If you have an integral like this where you can factorize the denominator, then it's partial fractions. So let's factorize the denominator. 2 over x minus 3, x minus 1. We'll give you credit for being able to do the partial fractions. This is equal to the integral of 1 over x minus 3 minus 1 over x minus 1. If you put those two fractions back together, you'll see that you get x minus 1 minus x plus 3, you get 2. Well, when you've got that, all you've got to do now is integrate log x minus 3 minus log x minus 1 plus c, or you can make it look a little tidier by writing x minus 3 divided by x minus 1 plus c.